Hi everyone, I am Dr.N.PRABHA, Associate Professor and Head Department of Chemistry, A.D.M. College for Women. Today, I am going to discuss about chemical bonding. This unit belongs to first BSc Chemistry in Unit 3 for General Chemistry 1. What is meant by chemical bonding? Matter is made up of one or different types of elements. Under normal conditions, no other element exists in the independent atom in nature except noble gases. However, a group of atoms is found to exist together as one species having characteristic properties. Such a group of atoms is called a molecule. Obviously, there must be some forces which hold these constituent atoms together in the molecule. The attractive force which holds various constituents, that is, atoms or ions, etc., together in different chemical species is known as the chemical bonding. So, chemical bonding is defined as the attractive force which hold the various constituents together in different chemical species, that is chemical bonding. What are the types of chemical bonding? Ionic bonding, covalent bond, dative bond, hydrogen bond, van der Waals forces and London forces. What is meant by ionic bond? Ionic bond is otherwise known as electrovalent bond. Electrovalent bond is that bond which is formed when one or more electrons from the valency shell of the atom are completely transferred to the valency shell of the another atom. That is, highly electropositive elements in the electrons are transferred to the highly electronegative element. That is the ionic bond. Thus, an ionic bond is established between two atoms whose electronegativity difference is very high. The atom that loses electrons becomes positively charged, that is cation, while the atom that accepts electrons becomes negatively charged is known as anion. The cations and anions thus obtain or then attract towards each other by the electrostatic force of attraction and thus linked together by an ionic bond. Thus, an ionic bond can also be defined as the electrostatic force of attraction existing between the cations and anions of an ionic compound. In the formation of ionic bond or ionic compound, energy is released. The formation of the cations and anions obtained by the loss or gain the electron attain the nearest noble gas configuration. Let us see one example, that the formation of ionic bond in sodium chloride. In the sodium chloride, that the electronic configuration is N1s2, 2s2, 2p6, 1s1. In the chlorine configuration, that is 1s2, 2s2, 2p6, 3s2, 3p5. So, that the sodium atom, it loses the electron and converted into the sodium ion, and the chlorine, it abstracts the electron that it converted into Cl minus. So, formation of sodium chloride, Na plus Cl minus, in the Na plus is converted into 1s2, 2s2, 2p6. And the that is in the chlorine Cl minus, configuration is 1s2, 2s2, 2p6, 3s2, 3p6. The compounds for the formation of the ionic compound, what are the criteria? First one is the low ionization energy of the atom, that is the metal atom. That the ionization energy of the atom should be low, so that this atom may lose the electron readily to form the cation M+. And the second point is the highly electron affinity of an atom X. That the electron affinity of an atom X should be high, so that this atom may accept the electron ready to form the anion X-. And the third one, high value of lattice energy of M plus X minus ionic crystal. Greater the force of attraction between the constituents ion in an ionic solid, greater is the stability of the ionic solid. Greater the magnitude of the lattice energy of an ionic solid, greater is the electrostatic force of attraction between the ions, and hence greater the stability of ionic solid, its lattice energy should be high. And the fourth one, electronegativity difference between metal and also halogen atoms are very high. The electronegativity difference between metal and also halogen atom should be very high, so that complete transfer of electrons from M, that is the less electronegative atom, to X, that is the halogen atom, more electronegative atom may be possible. General properties of the ionic solid. What are the properties of the ionic solid? That the ionic solids are soluble in polar solvents like water. They are not soluble in non-polar solvents like benzene, ether, alcohol, etc. Third one, they conduct electricity in solution and in molten state due to the presence of ion. Fourth property, they possess very high melting and boiling point, became the ions are held together by strong electrostatic attraction. The ionic crystals have high value of lattice energy. Ionic solids have very little elasticity. Seventh point, they possess very high density due to the close packing of ions. That the eighth property of ionic solids are highly hard and brittle. Aqueous solution of the ionic solid undergo ionic reactions very quickly due to the attractive force between the oppositely charged ions. The last property for the ionic bond is non-directional, and therefore ionic compounds do not exhibit stereoisomerism. In the next topic is the lattice energy. Lattice energy is important for the ionic crystal because the stability of the ionic crystal is measured in terms of lattice energy. Lattice energy is denoted as capital U. How will you define the lattice energy? Lattice energy of an ionic crystal is defined as the energy released when 1 mole of gaseous cation and 1 mole of gaseous anion separated from each other by an infinity distance are brought together to their equilibrium distance to form 1 mole of ionic crystal. That is, formation of the 1 mole of ionic solid A plus B minus from its constituent gaseous cation A plus gaseous and also B minus may be represented as, when it forms as the 1 mole of ionic solid, energy is released, that is minus U, lattice energy is released. And the another one definition for lattice energy is the energy required to move the ions of 1 mole of ionic crystal which are at equilibrium distance from each other to a definite distance. That is, the lattice energy of the ionic crystal is the energy required to convert 1 mole of ionic crystal into gaseous cation and anion. This time, ionic crystal it absorbs the energy, that is plus U. It can convert it into gaseous cation and anion. The lattice energy is represented as minus U. That is, in the above definition, the negative sign indicates that the formation of an ionic solid from its gaseous cation and anion is an exothermic process. That is, the formation of ionic solid, there is the release of energy, and hence the energy of the system is lowered. This is because of decrease in energy. The ionic solid is more stable than the individual ions of which the ionic solid is made up of. Greater the value of lattice energy of the ionic solid, greater will be the stability of the ionic solid. We see for some examples. The melting point of sodium chloride, potassium chloride and cesium chloride. These are the first A group elements in a periodic table that combined with the halogen atom, the melting point or decreases in the same order. This is because their lattice energy decreases in the same order 184, 168 and 151 kilocalories per mole respectively. How will you calculate the lattice energy? How will you calculate and how will you determine the lattice energy? That is the Born-Haber cycle. The direct determination of lattice energy of the ionic crystal has been carried out for only a few compounds. In few cases, it is not possible to measure the lattice energy directly, but Born-Haber cycle devised a cyclic process to find the lattice energy. In the Born-Haber cycle can be explained taking the formation of sodium chloride for elementary solid sodium and elementary gaseous chlorine. Let us make the following assumption. In this first process, sodium metal is evaporated to sodium atom. That the NaS is evaporated into Nag, that is in a gaseous sodium atom. That process is known as sublimation. The energy of sublimation is plus S. In the second one, the diatomic chlorine gas, Cl2 gas is associated to chlorine atom. Molecule is converted into atom. The energy is of dissociation of chlorine molecule is plus G. The third one, that the evaporated sublimated sodium atom and also dissociated chlorine atom combined together. That process Na plus ions. The sodium atom are ionized to form Na plus. That it becomes, sodium atom becomes as ionization. So the ionization energy of sodium atom is plus I. In the chlorine, electrons obtained from sodium atom are transferred to the chlorine atom to form negative chlorine ions. So electron affinity of chlorine atom is minus E. So the lattice energy of sodium chloride is calculated is minus U. The heat of formation of the crystal from its element is minus Q. That is the total energy of the system. Total energy of the crystal formed from its elementary compound minus Q is equal to plus half D plus I minus E minus U. That is, we can calculate the lattice energy. So, we can change the order. U is equal to Q plus S plus half D plus I minus E. Q is the total energy. U is the sublimation of the sodium atom. Half D is the dissociation of the chlorine molecule. I is the ionization energy of the sodium ion. E is the electron affinity of the chlorine ion. So, we calculate the lattice energy U. The value of Q are accurately known for many substances, knowing the other thermochemical values. It is possible to calculate the lattice energy. Next, we see the application of lattice energy. What are the applications? With the help of lattice energy, we can estimate electron affinity, proton affinity and heat of formation. It is applied in the discussion of special properties of fluorine in relation to other halogens. It is applied to account for the stabilities of metal chlorides, hydrides, polyhalides, peroxides and superoxides. It is applied in the derivation of crystal field stabilization energies. It is applied to account for the occurrence of high oxidation states of metals in their fluorides and low oxidation states in their iodides. In the next we see for the new term, that the polarizing power. This is because for the next we move from the Pajan's rule, that the basic terms are the polarizing power and the polarizability. What is meant by polarizing power? The ability of the cation to polarize a nearby anion is called as polarizing power or polarizing ability. The next one is the polarizability. The tendency of an anion to get polarized or distorted by a cation is called its polarizability. Thus, in the ion polarization, the role of cation is to distort the electronic cloud of the anion because of its polarizing power. The role of anions is to get distorted by the cation because of its nature of polarizability. What are the effects of ion polarization? Due to the ion polarization, some covalent character is introduced in the ionic compound. The second one, ionic polarization occurs for variation of melting points in ionic crystals. So, in the ionic character, in ionic compound to introduce the covalent character, so that the ionic compound is partially ionic character. So, the partial ionic character from electronegativity. We have seen the covalent bond is set up by sharing of electron between atoms. If the electron pair is shared equally, the bond is non-polar. If the electron pair is shared unequally, the bond is polar. For example, hydrogen and chloride are called non-polar because hydrogen molecule H2 and Cl2, both the atoms are the same atom, that the electrons is shared equally. So that compound, hydrogen molecule and chlorine molecule are non-polar molecule. Suppose if in the case of hydrogen fluoride, that is the polar molecule because HF. H is one atom, fluorine is the another atom. That is the shared, the electrons are not shared mutually. Fluorine has the greater attraction of the electron because that the fluorine is a more electronegative atom than the hydrogen. So the shared pair of electrons is the nearest to the fluorine atom than hydrogen. So this makes the covalent bond polar in nature. This is called the partially ionic character. How will you calculate the ionic character? The electronegativity of the B can be used to calculate percentage of ionic character in the polar covalent bond. If you consider as the AB as a molecule, A is one atom, B is the another atom, are linked by the polar covalent bond. The amount of ionic character in this bond depends on the difference in electronegativity values of A and B. If the difference of electronegativity values Xa minus Xb greater the value Xa minus Xb, greater the percentage of ionic character in A and B. Here the electronegativity of ionic compound is summed to be greater than that of the B. That the Pauling has estimated the percentage of ionic character in various polar covalent bonds. If the values of Xa and Xb becomes as equal to 1.7, that the 50% of ionic character is there. That the nature of AB bound is 50% covalent, 50% is ionic. If it is less than 1.7, less than 1.7 means it is predominantly covalent character. It is greater than 1.7 means it is predominantly ionic character. So, that the ionic character is transition to the covalent character in a ionic bond. For this discussion, we come to know that the compound is neither 100% covalent nor 100% ionic. When there is the difference in electronegativities between two covalently bonded atoms, it develops the partially ionic character. In an ionic compound, there may be ionic polarization causes a partially covalent character. Thus, there is the transition between ionic and covalent character. Now, let us see what is the statement of Fajon's rule. The Fajon states that the various factors that affecting the magnitude of the polarizing power of a cation and the polarizability of the anion are suggested by the Fajon. This is known as the Pajan's rule. So what are the factors affecting the Pajan's rule? First one is the size of cation. If the size of cation is small, it will be the greater polarizing power on anion. If the size of the anion, if the size of the anion is large, it will have the greater tendency to get polarized by cation. When an anion is small, balancing electrons are nearer to the molecule and hence the tendency to get polarized by the cation will be less. But when the anion is large, it is polarized easily. Third one, that is the charge on ion. As the ionic charge on cation increases, the polarizing capacity also increases. That is, let us see one example. Let us consider Ag plus and K plus, silver ion and potassium ion, whose ionic radii are 1.13 angstrom and 1.133 angstrom respectively. Because the smaller size of the Ag plus will have the greater polarizing power when compared to the potassium. Another one example, Na plus and Al3 minus. Al3 plus, Na plus and Al3 plus. Al3 plus has got more ionic charge, it will get greater polarizing power. So what are the factors affecting the transition from ionic to covalent character and vice versa? First one is the decreasing in melting point. Due to the transition of ionic to covalent bond, melting point is decreases. Suppose we take in a first A group element, that is sodium, potassium, rubidium, cesium. That forms as a salt, sodium chloride, potassium chloride, rubidium chloride, like that. That the melting point of sodium chloride is 801 degree centigrade, potassium chloride is 770 degree centigrade and cesium chloride is 650 degree centigrade. When moved down in a group, that is Na plus, K plus, Cl minus, the size or increases because their atomic number increases. The polarizing power is decreases. So, ionic character decreases. So, their melting point also decreases in the same order because ionic character and melting point are directly related to each other. Let us see the another one example, that the calcium fluoride and calcium chloride. Melting point of the calcium fluoride is 1329 degree centigrade. But in a calcium chloride 772 degree centigrade, because fluorine and chlorine atoms, ions, the ionic size of chlorine is greater than that of the fluorine, because the atomic number of Cl minus is more than that of fluorine. So Cl minus is more polarizable than F minus. This makes calcium chloride less ionic than calcium fluoride. So its melting point is also less than that of the CaF2. Next we see the decrease in ionic character. The ionic or polar character of the following pairs are as follows, that the HF and hydrogen iodide, sodium fluoride, sodium chloride. In the between HF and HI, the more ionic will be HF because I minus is more polarizable than fluorine ion due to the larger size of the I minus. In a sodium fluoride and sodium chloride, that the more ionic will be sodium fluoride because chlorine minus is more polarizable than F minus. Due to the larger size of Cl minus, the same reason for the other elements for the lead fluoride, lead chloride and magnesium chloride and silver chloride molecules. The third point is the increase in covalent character. Among the sodium iodide, sodium chloride and the lithium iodide, the covalent character or increases. Okay, that is the lithium iodide will have maximum covalent character. This is because Sodium chloride and sodium iodide, more covalent will have the sodium iodide. Sorry, lithium iodide. This is because I minus is more polarizable than chlorine minus due to the larger size of iodine. Between sodium iodide and lithium iodide, the more covalent will be lithium iodide. This is because Li plus is smaller than the Na plus. So Li plus will have more polarizing power than the Na plus. Then last one is the decrease in electrical conductivity. Fused beryllium chloride shows poor electrical conductivity, but fused magnesium chloride is a good electrical conductivity. This is because Be2 plus is smaller than Mg2 plus. So it will have more polarizing power than Mg2 plus. Because of this, it polarizes the electronic cloud of chlorine more than magnesium. So BeCl2 becomes less ionic and more covalent. So its electrical conductivity is less. So in the light of the transition from ionic to covalent character, it will discuss the reverse vice versa. Transition from covalent to ionic character, the whole discussion will be the reverse direction. Let us come to the conclusion. Between two cations with a similar nuclear charge, smaller cation will polarize more. The second point, between the two anions with similar charge, the bigger anion will be polarized more. Third one, between cations with different nuclear charges, the cation will polarize more. Last one, polarization more means the covalent character is more, ionic character is less, melting point is less, electrical conductivity is less. Now, in this module we see what is meant by chemical bond, what are the types of bond and ionic bond, and in the ionic bond we see how will you calculate the lattice energy and the Pajan's rule. In the next module we see the covalent bond. Thank you.